All right, so finally, I think that we are ready to put all of these pieces together in order to find the derivative of the arc sine of x. And we're going to do that using some implicit differentiation on the sine of y is equal to x. Why is that? Why is that? Okay, so here's the thing. I'm going to take y being equal to the arc sine of x, and we don't have a derivative formula for that. So one of the things that I can do to both sides of the equation, I can multiply it by 2 if I wanted to, I can subtract 5, or I can take the sine of both sides. And that's what I'm going to do. And why am I going to do that? Because I know the derivative for sine. So I have the sine of y is equal to, and on the right-hand side, the sine of the arc sine will cancel out, giving us an x specifically over a particular interval. Now, I'm going to take the derivative of both sides of this implicitly because I have a y inside of my sine. So the derivative with respect to x of both sides of this guy. What is the derivative of sine of stuff? It is the cosine of that same exact stuff. Now, since that stuff had a y in it, I need to multiply it times dy dx, or y prime, is equal to, what's the derivative of x? 1. Okay, and now, just like with any implicit differentiation, you now have to solve for dy dx, so we'll divide the cosine of y over to the other side, and I will get dy dx is equal to 1 over the cosine of y. Cozy. Yeah, but I don't want y up in my derivative. I need to do some back substitution. And what the heck was y equal to? Y is originally equal to the arc sine of x. So let me back substitute that in here, and I get dy dx is equal to 1 over the cosine of the arc sine of x. So far, so good, yes. But hey, I'm pretty sure we've done something like this. This is a composition of trig expressions, and I have arc sine inside of cosine. Of course, those things don't cancel, but I can turn this into an algebraic expression, right? I think we've already done this. The arc sine establishes an angle for me. Wait a minute, did I already do it? Wait, I'm not going to do it again. It's right there. It's supposed to be the square root of 1 minus x squared. Yeah. Don't do it again if you've already done it. 1 over the square root of 1 minus x squared. Okay, what the heck? Let me just kind of recap this. The derivative with respect to x of the arc sine of x is equal to 1 over the square root of 1 minus x squared. Notice, there's no trig in its derivative. The derivative of the arc sine is something completely algebraic. Very curious. Okay, all right. Now, I am going to try the same kind of thing on the arc sine of 2x. So notice that this is like a composite function here. If you knew its derivative rule, you could just apply the chain rule to it, but we're going to take the antiderivative, or not the antiderivative, what am I thinking? I'm taking the derivative of this implicitly. And once again, I'll take you through the steps. Y is equal to the arc sine of 2x. I don't have a formula just yet for the derivative rule for arc sine, so instead I'll take the sine of both sides. And when I do, I'm going to have sine over here on the left-hand side, and the sine of the arc sine of 2x is going to return the 2x back to me. And then I would want to, oh, no, actually, I just leave it like that. Now take the derivative. Let's take the derivative of both sides with respect to x. Okay, the derivative of the sine of stuff is just like it was before. It's the cosine of that same stuff, cosy, times the derivative of that interior function, which is y prime, or dy dx if you prefer. And then what is the derivative of 2x? Just 2. Okay, and now let's solve it for y prime by dividing 2 over cosine of y. We don't want y up in there, so we're going to replace it with what y is actually equal to, which is the arc sine of 2x. Okay, all right, so then we didn't do this one before, so we will have to go through the process of turning this back into an algebraic expression here. That establishes an angle, and that angle looks like this. The sine of something is equal to 2x, or 2x over 1, so we can have a ratio. When we draw that thing in the coordinate plane, we'll draw it in coordinate or quadrant number 1 because sine is perfectly acceptable there. Here's our angle, and our opposite side is 2x, and our hypotenuse is 1. And then whenever I use the Pythagorean theorem, I'll call this thing an a down here. A squared plus 2x squared is equal to a 1 squared. Remember to square both of these things, so it's a 4x squared. Subtract, take square root, and I can see that a is equal to the square root. It's really plus or minus, but for right triangle stuff, we only keep the plus 1. 1 minus 4x squared. So put that on the bottom of this thing. It's equal to 2 over the square root of 1 minus 4x squared. So let's see if we can put the pieces together here. The derivative with respect to x of the arc sine of 2x is equal to 2 over the square root of 1 minus 4x squared. Okay, let's see if we can put these little pieces together before I let you try one on your own. Okay, because we don't want to always have to do this particular thing. We don't want to always have to basically turn it into a function that we already have the derivative rule for. We're trying to establish a derivative rule for arc sine, arc cosine, arc tangent specifically, okay? Okay. So where do you think this 2 up here came from? Look at the original function. Where do you think this 2 came from? And let's look at what we had up here on this one. I had only a 1 up here. That is the derivative of the interior function here. The derivative of 2x is this 2 that's right up there. Okay. Now, notice that this one has a 4x squared inside of there, a 4x squared. And the original one here, whereas the original one just had an x squared. It was this thing that was being squared. And the reason why it was that x squared, because remember, it's basically the Pythagorean theorem thing. It's this, oh no, are you kidding me? All right. It was originally like this side x, and then we had to use the Pythagorean theorem and got an x squared that was inside there. And then we did the same thing on this one. We had a 2x on our right triangle, had to use Pythagorean theorem on it. That 2x became a 4x squared after we squared it. That is this thing, this 2x that's being squared inside of there, all right? Right, so that's where that thing came from. So here's one that I would like for you to try then. I want you to do the exact same thing that we have done, this previous one, to find the derivative of the arc cosine of x. So follow the same exact steps. Turn it into the cosine of y is equal to x, and then take the derivative of both sides. You'll get a composition of trig functions like I did up here, and then you'll have to resolve it and turn it into an algebraic expression. And something spectacular will happen. Let's see what it is.